Hello everyone, and welcome back to Adrian's Digital Basement 2. On today's video, well, it's on my lap. This is what we're going to be talking about. A little Panasonic television. And isn't it a beauty with this green color on the side? I'd almost call it olive green, but it's more of a light green color. Very 70s looking, and I love that about it. On the front of the TV, there's a smoked plexiglass cover over the CRT. Makes the TV look a little bit more sleek and nice. But I think one of the issues with these smoked covers is that you have to turn up the brightness and the contrast higher on the set to get a similarly bright picture because, of course, it's covered with a tinted plastic. So that means that it might be driven harder over time, which may mean that this thing is just totally worn out. This was saved from e-waste and given to me recently by a viewer here in town. And I have no idea, of course, if it works. That viewer did not try to test it or anything like that, so we're gonna do that today. Well, as you can see a little closer up, it is a little bit dirty. We got a UHF tuner here, and it's a variable knob, meaning it doesn't have indentations for the various channels. Of course, it does go up to 80 or 83, because that is UHF back in the old days here in the US. VHF tuner on the bottom, it's pretty normal. It's got the cheese grater speaker grill, very much like the current Macintosh Pro. So maybe Apple took some inspiration from this old Panasonic TV. As is typical with a lot of sets of this time, the top knob is the volume and the power switch, so you turn it all the way down and click it off to turn the set off. Contrast and brightness. Looking at the sides of the set, there are no headphone jacks or anything like that, just a little bit of dirt and scuffs. Same thing on this side, nothing much to report. Back of the set, we have a bar antenna, which is broken off, a carry handle, which works quite well, unlike that last TV that I reviewed, where when you picked it up, due to the angle of the inside of the handle, it felt like the TV was gonna slip off your fingers. Not so with this one. 300 ohm VHF antenna input, and obviously this twin lead here is what comes from this bar antenna. And then below we have a UHF. I'm noticing a typical Japanese fashion, there's an arrow pointing to the screw here, obviously telling me that I need to remove that screw when I disassemble this set, which I'll do shortly. This TV is UL listed. See if I can get that not to reflect so badly. No, it's really hard to see. It does say TV and 828B, like Baker. Here's the badge label, Panasonic AN-809, 120 volts, 60 hertz, 110 watts. That's an extreme amount of power for a TV set this big. I think it looks like it's 8 or 9 inches or so. Made in Japan, of course, as Dave Jones says, all the best stuff is made in Japan. Looks like a FCC type certification sticker here. It's a little hard to read, but that might be the serial number, but maybe not, it's hard to tell. Someone's wrapped up the power cord here, which I will unwrap. It's nice that these plastic things for the holding of the power cord haven't snapped off as they have on so many of these old sets, just because the plastic gets so brittle. Relatively standard issue affair back here. The power cord says interlock over it. There's a height control, a vertical hold, vertical linearity, and a horizontal hold. And a whole lot of dust inside of all these vents here. It's just kind of coming out. So that might indicate that this set has had a ton of use, and the convection and the heat of the 110 watts that this thing takes up or uses has sucked a lot of air through these bottom vents and gone out the top, probably bringing all this dust in with it. Take a look at the plug here. Looks like someone has yanked it out of whatever outlet this was plugged into. You get this happening when you sort of pull it out by the cord and you get just one prong in there at an angle and you yank it really hard. You end up with a bent pin like that. And this is not a polarized plug whatsoever, so this is almost certainly a hot chassis. I guess we'll find out if there's a transformer in here in a second. But it does have this little thing on the top of the plug here, and that is for wire management, so you can push the power cord into it. Well, that would be how it's supposed to work, but due to age, this is just pretty stiff, rubbery plastic here. So it doesn't really work so well anymore, but that's what that was originally for. You wrapped it up on here, and then you would clip this onto the wire just to hold it on. All right, well, let's take this thing apart. Let's take a look inside and see how bad the dust really is. Got a couple screws up in the top, and I do see the little arrows in there. Very nice Panasonic. It cracked a little bit when I started taking the screw out. It's kind of indicate to me that maybe no one has been inside this TV before. I think the general consensus whenever I have a Panasonic TV on the channel is that they are very reliable, generally not being problematic. Oh look, there's a serial number on the bottom, FT3453037. Now I saw no date code anywhere on this thing, although I have to say I did a little bit of searching around on the internet and it seems like the conclusion is 1973 for this TV, so it is older than I am. These screws on the bottom, incidentally, do not have the arrows, so I'm not quite sure about that, if these actually need to come off. These look to be screwed into the chassis somehow, though, because these are metal screws. They're not the self-tapping type. Okay, a bit of gunk is coming out of the TV as I flipped it around there. All right, I've learned from these old TVs that this power cord almost certainly is connecting to the bottom of the chassis. So when I pull this off, it's gonna be really stiff because the cord's gonna be stuck into the two power prongs. All right, I've released it. I ended up using a PC slot cover in one of the vent slots here just to hold the PCB while I tried to pull the back cover off, because definitely this power cord was really stuck to the two pins, the power input pins on it. So now this thing is free. All right, and there it is. Well, so definitely one of the reasons why this thing uses 110 watts should be evident at this point. This television runs on vacuum tubes. So I'm not so sure about the 1973 date when this thing is vacuum tubes. Now, personally, I have never actually worked on anything that uses vacuum tubes. I don't know the first thing about it other than watching YouTube channels about them. I do know things like dim bulb tester are good things to have when you're powering these things on, because short circuits are a possibility, especially with old caps and things like that, that could result in destruction of various things inside the set. The dust in here is definitely a real thing here. Now, like, just look at this. Now, I know there are people like Shango66 and others that say clean out sets like this is not a good idea before you work on them, but that's not really my style, and I don't even know what I'm doing here. So I'm probably gonna take this outside and at least just hit it with some compressed air. I'm not gonna shoot the compressed air right close up to things. I just want to get a lot of the bulk of this stuff off, although there's a bit of a smoker's smell to this thing, cigarette smoke, so I guess it's been smoked around. I think there was definitely a time in the US in the 70s where sets were sold with both vacuum tubes and transistors at the same time. This might be one such set. Now, it's so dusty in here, it's really hard for me to see if there are transistors in here, but I'm definitely seeing a lot of tubes. Let's see if I can count the number of tubes. We have 1, 2, and over here, there's 3, 4, 5, and 6. The 5th and 6th are up here on the tuner. And then we have 7, 8, 9, and 10 with this big one right here in this kind of like cage of sorts. Must have something to do with like the horizontal output going to the flyback, which is right here. Flipping the set onto its side here, you can see that of course it does have a PCB. So this would be unlike the earlier tube stuff, which has point-to-point wiring inside and there's all the caps and whatnot underneath here. And I think the general consensus is that vacuum tubes and PCBs don't really mix and match very well because of the heat cycle you have going on from the hot vacuum tubes and the solder joints. They frequently crack and break, which cause, of course, issues, as we well know about. It does say right here, chassis number N95 for the 9-inch and N95A for the 12-inch. So I guess there's two different variants of this particular set using the same PCB. And the tube in here is a Panasonic tube, but I don't think you can read the number. It's blocked by these components here. 230 AEB4, and then after at the end here says TYC. I'm looking at the PCB, looking for any kind of diodes or transistors, and I really am not seeing anything. And here's the diagram showing the adjustments and the tubes and whatnot. You can see right here that this is the mains input connection. It's definitely a hot chassis because one side of it goes to ground on the actual chassis. And of course, it's a non-polarized plug. So you could easily plug the live into the hot chassis ground. So no for working on this set without an isolation transformer unless you risk getting a shock. That big tube here says horizontal output and damper, which is kind of what I thought it is. Then this tube, horizontal oscillator and AGC. This tube, vertical oscillator and output. Looks like this tube over here is for audio output. And then this is for video amplification and IF stuff, so intermediate frequency. And then up here, the tuner has a couple tubes on it as well. And looky, this is actually a hybrid set. There are some diodes here. Diode 2002 sound detector, 201 sound detector, and 101 is video detector. So there's a little bit of a sound circuit right here, and I think this is the other diode right here, and that would be the video detector right there. Noticing up here, there's a couple spider balls. So this thing has been in the dust. All right, I'm gonna take this outside and try to blow this out a little bit. All right, dusting off is complete, and it's definitely a lot cleaner inside. It's still not perfect, of course, because, you know, there's a ton of dust. So looking around in here, it is all the original vacuum bulbs or tubes, Matsushita. So I don't know, it's certainly high hour. There's a lot of evidence that this thing has been run a lot. Inside of the case has a lot of black soot on it from the high voltage. So it's well used, this set. But anyhow, this cap here is an electrolytic. I wrote the three values that it is. It's 250, 210 microfarad. The writing is on the side. It's really hard to see there. Most of the other caps on here are not electrolytics. There is one other electrolytic right here. It's just a little purple capacitor. See it right there by my index finger? I gave the underside a little inspection just looking for any broken solder joints, and actually I don't see any. So I think at this point, I guess I'm ready to try this thing out. Now I have the isolation transformer here on the bench. This was sent in by a viewer several videos ago, so thank you very much for that. I do use this thing when necessary, and I actually do intend to mount this thing on the wall here, but under the desk, and then have a permanent outlet up here that is through this thing with a power switch to turn the whole thing off and on. Now, I had mentioned dim bulb tester before, and I have never actually used a dim bulb tester, but I'm going to try to do that here. This little bit of a mess is one such thing. So mains power comes in through here, kilowatts, so we can see the current draw. So the whole idea, from my understanding of the dim bulb tester, is with vacuum tube stuff, you want to hook up a light bulb in series with the set itself. And that's because, from my understanding, unlike silicon transistors, you can run this set at a lower voltage than it expects. So it wants 120 volts, that's what it's designed to do, but you can power it up at, say, 60 volts, and it generally may work. Not everything might work. There might be no high voltage or horizontal sweep, but you can kind of get the thing starting to work just to see if anything is gonna short circuit and cause a fire or whatever in the set. Now, when you hook up the light bulb, the thing that's interesting about it is that if there's a short circuit in the set, the light bulb will just be full intensity. Say you put a 60 watt light bulb in there, and then the set is only gonna be absorbing that 60 watts of power as opposed to the full short circuit. Now, there is a fuse on here somewhere, so that would probably blow if there was a short circuit, but think of the light bulb as a really high power current limiting resistor, which is what it is, which just helps protect things. Now, what this was originally is it had a switch on the end of this cord, an on-off switch, and then you plug this into the mains, plug a light or whatever into here, and then you could turn it off and on. So essentially, the power comes in here, goes through this cord all the way down to the end, comes back, goes on this outlet, and then the other one is connected straight through. So it's a way to interrupt it. Now, what I've done is I have cut this switch off, put this little joining block, a couple clip leads, so I can clip it on to the set here. And then obviously whatever I plug into here is going to be in series with the entire thing. So I have this, which is just a regular light bulb socket thing. So this will allow me to screw a light bulb into here, and it has an on-off switch as well, which actually shuts the power off to the whole thing. And that should work, I think. The people are probably yelling at their screens that I should replace caps or test the tubes first or a whole litany of other things. I don't have any equipment to do that. So I'm in uncharted territories here. Remember that this TV was saved from e-waste before it got to me. This was literally about to be destroyed forever. So at least now this set has the possibility of living, and maybe it works. So enough babbling, let's test this out. I'm gonna start with this Philips 40 watt light bulb here. Actually, what I'm gonna do first is I'm gonna clip these together so we can see what this looks like under full short circuit condition, just testing that it should work as advertised. All right, so the isolation transformer is on. Boy, this is not readable, is it? All right, well anyways, if I turn on the power switch here on this cord, there we go, we have 39 watts, so that is working. With these clip leads disconnected, when I turn on the power switch now, we have nothing, of course, because the circuit is broken. This thing is all in series here. I'm gonna make sure the set is off on the top here. Turn this on. Interesting, the set is off, and yet the set is consuming 19 watts of power right now, even though it's off. So does that mean this thing has like a quick start feature where it kind of warms up all of the tubes even when the thing is off, so it turns on quickly? I think things in the 70s, a lot of them had that. So one thing that's interesting is it's now at 18 watts, so it's gone down by 1, and the bulb, as you can see, it's just on dimly here. So yeah, that pretty much confirms that this has some kind of standby feature, which from my understanding, it bakes all of the tubes because it runs their filaments at a low current. Like there's a resistor in series here with all the filaments. It makes everything warm up quicker, but it means that it wears out the tubes a lot faster, or so I've heard from watching other videos. And it's now 16 watts, so it's definitely creeping down. The bulb is getting a bit dimmer here. So it's kind of amazing to think that this is the standby current of this set. Like it's off and you think that it's actually off and it's drawing this much power. And to be honest, that's with this light bulb. If I plug this set directly into the mains, it's gonna draw a lot more power than this 16 watts. All right, well, let me try turning on the TV and let's just see what happens here. I don't expect it to work, not with a 40 watt light bulb in here, but yeah, who knows? Here we go. So it's drawing 31 watts now. The light bulb got brighter, obviously. Let's see if there's any sound. No sound. Now people talk about electrolytics and reforming them, and that would be for like this electrolytic capacitor right here. Apparently, when they haven't been used a long time, they can kind of be more of a short, like they have a lot of leakage. And as you apply power to them, they will sort of reform or start to work properly. And you'll see on a kilowatt here, you'd have a higher power draw and it would drop down as everything kind of reforms. Now, personally, I've never experienced that happening. I've certainly seen people's videos where that seems to be the case, but obviously on this set, it's just sitting here at 31 watts and nothing has really changed. I've gone ahead and I've shut off all the lights here. I'm gonna turn the set back on and I'm gonna cover the bulb. I just wanna see if any of the tubes are warming up. I don't see any filaments warming up at all. I'm gonna power off the switch here. So that means the TV is no longer live with any power at all. And I'm gonna pull out one of these tubes here. I wanna see if the filaments on this set are in series, and removing one of them means that when I turn this thing back on, when I turn the power back onto it, the light bulb I don't think should light up at all. So let's see. And look, it didn't. Nothing at all. So that does mean that the filaments in all the tubes are actually working. And the filaments inside of these things are little heaters, basically, that heat up the inside of the tube so that it can function properly. Let's see if I can get this back in here properly. All right, since I don't know what's off and what's on, I'm just gonna take this light bulb out entirely. There we go, that's back in its socket. So I'll screw the light bulb back in again. Okay, I did have it off. If I turn the switch back on, uh-oh. Okay, I just reinserted that in there. Let's put this light bulb back in. And I put it back in and there was nothing happening, which, oh, there we go. Okay, it's, it's the socket. Not very reliable. All right, we're back to where we were again. Well, I think what I'm gonna do is swap this out for a higher wattage bulb. I think this one here is a 60 watt. Don't have a big selection of incandescent bulbs anymore. Let's turn this on. So we're getting 23 right now on this standby mode. And let's turn this on. All right. 42 watts now. And now with the set turned on, I am seeing actual filament glow out of the tube. So they are starting to glow, which means potentially this thing will make some sound. Nothing, no sound. But a dim bulb like this means that I don't think things are quite warmed up enough for anything to start working. Tubes don't work without the filament heating them up. They won't really conduct. So I have a light bulb splitter here. I'm going to use this to go up in wattage. So this is a 60 watt. And I'm going to screw this Y splitter in here. And I have this floodlight in here. I'm not quite sure the wattage of this. It does say it is 920 lumens though. So that is more than a typical 60 watt bulb. So we'll screw this in. All right, and if we turn this on, yeah, about 21 watts, and the set is off right now. So let's put the 60 watt bulb in here as well. So I think we should be getting the equivalent of 120 watts. 32, okay, it's all pretty dim right now. In fact, this light bulb's not even on. All right, let's turn on the set. 54 watts. Definitely have filament glow out of these tubes here. And I feel heat coming off of them as well. Sound? No sound. Definitely no high voltage either. Okay, I've upgraded the light bulb to this, which is that 3-way bulb. I think it's running 100 watts right now, plus the floodlight, and the set is running at 76 watts. So we're ramping it up. It's almost at full power. I think it's at 110 watts on the back of the label. And filament glow is happening on the CRT as well. Definitely no life to the TV though. Oh yes, there is sound, everyone. It's not loud, but I hear sound. So that means it's starting to come to life. This is so cool. So cool. And 77 watts, and it's not really changing. And no smoke and nothing bad is happening. It's just sitting here trying to work. Maybe I'll let it sit like this for a little while, just to make sure nothing goes wrong with it. And then I think it's time to bypass this whole arrangement here and just run this thing right off mains power. All right, the multimeter here is set to AC. Let's just see what voltage the set is currently running at. 90 volts, 89 volts. So of course, because we have a big resistor here, there's a voltage drop happening. So yeah, the TV is running at 90 volts. Obviously not quite enough, but almost enough for it to start working. Don't really hear too much else coming from the set, but of course there is warmth coming off these tubes because they are of course running. We're still at the same 77 watts, so definitely this thing's not going up or down in power draw, which is a good thing, right? Incidentally, you can buy these 3-way light bulbs at Dollar Tree here in the US still for $1. With light bulbs, when you're putting in a lower wattage bulb like this 40 watt bulb, this is the equivalent of a higher value resistor. And a bigger resistor, of course, creates a bigger voltage drop for the set and also would protect it and current limit it if something were to short out. When you put in these higher wattage bulbs, or 2 of them in parallel like I'm doing here, it's equivalent of a lower value resistor, which gives the set the ability to draw more current and more power and have less voltage drop across the light bulbs. I've been sitting here for a little while here and it's still drawing exactly 77 watts. So I think it's time just to run this thing right off the mains, see what happens. All right, isolation transformers unplugged from the wall, and I have a power cord here, mains one cut with one of these couplers on here. And I made sure to hook the neutral wire up to the left side pin on the TV because according to the diagram under the hood there, it showed that the left side one was the chassis ground. Not that it really matters because with that isolation transformer, that's providing the safety of this is now at mains voltage, but it's not referenced to the rest of the house, which creates an additional layer of safety if I somehow were to touch things. I'm going to turn this around so we can take a look at it when I turn it on, just making sure everything is all good on the back, and it is. I'll plug the kilowatt back in so we can keep an eye on the power draw. Let's plug this back in here. 34 watts. That is what this thing draws when it's turned off on standby. Oh boy. All right, here we go. 112 watts, 116, 121. All righty, and look at, as soon as the high voltage came up, dropped down to 95. Look at that, everyone, we have an image. How cool is this? But while it's rolling in the camera, things look pretty good on here. I'm gonna turn this off again. Look at that, no spot either. That is cool. Down to 31 watts on here. Now theoretically, because it's keeping the tubes warm here, if I turn this thing back on, it should come up pretty quick. Relatively quickly. Boy, it goes up to 130 watts when it comes up there. All right, well, at this point, it seems to be working. The pots aren't even that scratchy, which is a bit surprising. I need to hook up the test pattern generator to this thing so we can see if we can get an image on it. I'll just unplug it from this here. We have the handy dandy Sencore Universal Video Generator, the VG91. And I know several people have asked me to do a video specifically on this piece of equipment, which I will do at some point in the future. But the gist of it is it's a test signal generator, generates test patterns, and it can generate them and output RF channels, any of the channels that are supported by NTSC TVs here. So 2 through 83 and all the cable TV channels as well. So it outputs a video composite signal if you need. I think it actually has S-video as well, or the RF. And the RF with a TV like this is essential because it's a hot chassis set, so you can't just hook composite up to this easily enough, but I can hook up RF pretty easily enough to this thing, which we're gonna do right now. Now for the hookup, it's really ugly because this thing has a BNC output on the front, and this coax cable has F connectors on it. So I have an RCA to F connector adapter there, and on the front of the VG91, there's a BNC to RCA, and out of this cable is a 75 ohm cable, which goes into a balun. A lot of people corrected my pronunciation. I was calling it a balun, but it's a balanced, unbalanced converter. It's got a little transformer inside there that goes from 75 ohms to 300 ohms. And just for ultra jankiness, I have this, which I just recently found in a box, and it's a clip that clips onto the screw leads on the back of this. You don't even have to screw it on, and that is really crappy, and it doesn't offer a good signal, but twin lead 300 ohm, it doesn't offer a good signal anyways, especially when you have computers and LED lights and everything else that's like full of interference. So this is just easier. So I just clipped it onto the screw terminals on the back of the set. I'm gonna set this thing to channel 3, and let's plug in the TV, which will turn it on. This is also the true warm-up time of the set when it's not pre-warming up its tubes, which of course means it takes longer to wake up, but it also prolongs the life of the tubes, I would think. Look at that. Much, much, much longer wake-up time. There it comes. This is currently on channel 3. And indeed, we're getting pretty much nothing. Let's just turn up the output power. Okay, wait a second. Oh no, wait a second. Look, we got a signal. Look at that. Look at this, everyone. Pretty cool. It's very egg-shaped. See if the fine-tuning control works. It works. Look at this. I can't believe this old set is functional. And you know what? It's not even that bad. It's pretty bright, all things considered. Color me shocked. Color me shocked. Let's see about other channels here. So channel 4. 4 looks even better. 5 is not great. I think the tuner is just a bit dirty. There we go, that's not so bad. But 4 was the really clear channel. Look at that. Look at this. I can't even believe it. It looks great. It looks absolutely great. Well, it'd be nice if I had the camera set to the right frame rate. It's at 1/60th of a second now, so at least that bar is just sitting there. Let me see if I can adjust this a little bit more. No. There we go. That's about as good as it can get there. The image is very soft. Very, very, very soft. Like there are vertical lines here and I just basically don't see anything once you pass about here, but it's RF, which is already weak. And then of course, this is just an old set. Let's see if I peak it with the fine tuning a little bit. Let's send some audio to the TV. Well, audio is definitely working, so those diodes in there for the audio detector are good, and obviously the video detector diodes are good too. It seems like the audio and the video carrier are not quite right, because the audio is much louder over here than it is where the image doesn't have any static in it. Let's go up to the high part of the VHF band. Channel 13. Definitely some sensitivity issues up on the higher part of the VHF band, but not really an issue because 4 was working really well. Let's try UHF. So I set it to channel 14 on the VG91. Turn this knob here. to get down to 14. Oh, I'm clipped onto the VHF input on the back. Let me just move that. All right. There we go. Cool, the UHF definitely functions as well. So specifically on UHF, there's no fine tuning, which is this ring right here on the VHF, because you just turn this knob and it's the equivalent of the fine tuning. So it really seems like channel 4 is the best channel so far for this thing. Let's, I don't know, go to channel 40. Let's go up to 40 here. There it is. And it's looking pretty good as well. There's audio working really well. Wow, yeah, performance is really good up here. So I have the brightness all the way down right now, and we turn it up a little bit, the image appears immediately. So this set is actually really good. This CRT is strong. It is amazing. I am just surprised. And it's sitting here, by the way, at 91 watts. So why don't we see about trying to fix this linearity issue? There was a linearity control on the back of the set. So let me try adjusting that. All right, so this is obviously a size control here. All right, this control here is supposed to be linearity. Oh yeah, okay. That is, oh, it lost the sync. It's okay, let me turn these other pots here. Okay, now it's way egg shape on the wrong side. Let's fiddle with that again. It's nice that these controls are exposed. Hey, that's actually looking quite good now. Look at this. The whole image is shifted down a little bit. And to move this, we have to adjust the centering rings, which are on the neck of the CRT on the deflection yoke. That'll allow us to move the picture up. And then this should be a horizontal frequency control or horizontal hold. Seems like when I adjust it, it actually rolls over a little bit, but this does adjust some centering here. All right, so I'm going to try adjusting the centering rings. Or is there just one? The other centering ring is sort of behind a bunch of wires here. All right, with the quick adjustment, that's definitely a bit better. The whole thing is turned a little bit. It could have the yoke adjusted so it's rotated, but at least it's more centered, and this is less egg-like. It's not perfect, but you know, you can fiddle with these controls forever. It's an old TV. It's not gonna look perfect, right? Who knows how this set looked when it was new, so, you know, maybe it was never perfect, or maybe people have fiddled with those controls over time, right? Who knows? As is typical with these types of sets, it's got really bad DC restoration, meaning like the black of this particular test pattern is kind of a grayish color here. And if I turn down the brightness so that it's not showing up as gray, it's actually worse in the camera than it is to my eyes. That looks about fine. When I switch over to color bars or this ramp here, all of this is missing. And if I turn up the brightness, you see now we can see this. But if we switch back to here, look how washed out that looks. And that is because the cathode drive circuit on sets like this, a lot of these cheap black and white TVs, is just so simplistic that the overall picture brightness is affected by the contents of the picture. It doesn't need to be designed that way. You could design it a little bit better, and computer monitors, monochrome computer monitors, did a better job at that, so that the overall picture brightness is consistent no matter what's displayed on the screen. But these cheap TVs, it's just the way they were. You can't really fix this without redesigning that whole circuit. So I think that's it. There's not really much more to say about this set. It is absolutely amazing that it's such a survivor. All original tubes, tons of hours of use, and yet it still works. Good, bright picture. I mean, what else is there to say other than that's simply amazing? My first foray into testing out a tube-based set instead of regular transistors, and look at that, it just works. This really is one well-made little set. Fully functional, I didn't even have to use Deoxit on it, and it just works. If you have a set like this, I think they come in orange and other colors, make sure you unplug it when you're not using it because of course you don't want that like 35, 40 watts going into those tube filaments all the time unnecessarily, especially if it's something you hardly ever use. I'd imagine this thing got a lot of use and then was taken out of service unplugged and didn't just sit there on a shelf baking for 30 years, because it probably would have killed those tubes if that was the case. But the way it is here, this thing just fully functions, and I love it. I absolutely love it. I'm gonna put this back together, give it a little clean, put it on display somewhere, because it's so freaking cool. Anyhow, that's it for my second channel video on this awesome little Panasonic 9-inch TV. If you liked it, I'd appreciate a thumbs up. If you didn't, you know what to do, all the usual YouTube stuff, subscribe and comments below. Huge thanks to my patrons. Their names are scrolling up the side of the screen. Well, I've actually lazily switched it from this side to this side, so maybe their names are scrolling up over here. Anyways, thanks to all those patrons for all the support. I really appreciate it. If you want to become a patron, you can do so. There's a link in the description below. And of course, check out my main channel if you haven't already, and hit that subscribe button for my second channel if you haven't as well. It really helps me out. All right, that's gonna be it. Stay healthy, stay safe, and I'll see you next time. Bye-bye.